Good evening, all. Sorry, I thought I had a video on the right triangle trig, but I did not. So here it is. Let's try to get it in very quickly. I'll try to make it as short as possible, just to give you guys a quick basis um, for you to complete the homework. The homework, by the way, is going to be page 1 and page 2 in the packet. Right. So to get started, first of all, you will need some paper because I did not leave any space in the packet for writing or anything today. So make sure you grab a piece of paper and let's get started. So here we are. The right triangle trig. So this is our next section. I think it's 9.3 for us. I'm really not sure our text order, but here we go. So for right triangle trig, we'll just use this as our sample. As our sample here for our first couple of examples um, with our right triangle trig. So for right triangle trig, this is leading up to us using our sine, cosine, and tangent, and that's going to be another method for us to find ultimately another method for us to find missing angles and missing angles and sides in right triangle. Um, there is a mnemonic that we use to help us memorize for these trig ratios, and that mnemonic is so, so. Now, I used this mnemonic when I was in school, as well as pretty much everyone. So, it is pretty helpful. And again, I would recommend you just quickly write it down at the top of any worksheet, test, etc., that we're doing in this section. And essentially, it's just there to make sure you get the order of the ratios. You get the order of the fractions correct. All right. So, what does this stand for? Our so, we'll talk about that one first. What so stands for? It's going to be the sine of an angle, we'll say x, is equal to the opposite side over the hypotenuse. So the O is for opposite, the H is for hypotenuse. So that's where our so comes from. Next we have our ka, and our ka is a mnemonic again for our cosine. Now you heard me say sine, even though it looks like sin, because the actual word is sine, but SIN is like the abbreviation that you'll see on the calculators, stuff like that. Just like for this next one, it's cosine, but the abbreviation is cos. So the cos of an angle x is equal to, again, a over h stands for the adjacent side over the hypotenuse. Now, when it comes to when we're actually doing the work and calculating and using our calculators, if you have the ratios wrong in the wrong order, you're going to get the complete wrong answer or even like an error message, etc. So the order of these is important. So that's why we want to make sure we are putting the right thing first. And then our last trig function is the tangent, and it's TOA. And again, we abbreviated tan. And the tan of x is the opposite side over the over the adjacent. All right. So all we're going to do today is just practice writing some of the ratios in this packet. This packet is just the trig ratios. So tomorrow we'll get into like the actual solving and using the ratios, but today is just being able to write the ratios. So it's like one thing at a time. All right. So let's get started. So we have this example here, and I'm going to start with angle A. I'm going to do all the trig ratios for angle A. So I'm going to write the sine of A, I'm going to do the cosine of A, and I'm going to do the tangent of A. All right. So here's my angle A. Now from angle A, again, I'm doing my sine. Sine is opposite over hypotenuse. So sine of A is going to be which one of these sides? We have three. Now, when we do the ratios, we're using like the values or the lengths of the particular sides. So which side is opposite angle A? Is it the 3? Is it the 4? Is it the 5? Here we go. It is 4. So it's going to be 4 over the hypotenuse. So the hypotenuse is this side here opposite the right angle. So our sine of angle A is 4/5. And that's all you have to do. We're just writing the ratio. Now we need to find the cos of angle A. So same angle, cosine is adjacent over hypotenuse. So if you guys remember throughout the year, we keep saying adjacent angles, adjacent side, etc. It means neighboring or next to. So if we're talking about angle A here, what's adjacent to it? We technically have two choices. We have 3 and we have 5. But obviously, if you had to guess, I'm pretty sure everybody will lean towards 3, being the adjacent side, and let's address why. 3 is the adjacent side because we know that 5 is the hypotenuse. The hypotenuse is never going to be anything but h, like in these situations. It's the hypotenuse. It's never going to be the opposite. It's never going to be the adjacent. It's simply h at all times, simply the hypotenuse. So in this case, even though 3 and 5 are technically adjacent, 3 is the adjacent side and 5 is the hypotenuse. So our answer is 3/5 for that. Adjacent over hypotenuse. Adjacent over hypotenuse. And then our last trig ratio for this one, sine of A, is opposite over adjacent. So again, opposite angle A is 4 and adjacent is 3. So these are our first 3 trig ratios we're practicing for angle A. All right, so now let's do the same things for angle C. So I'm going to do sine of C, cos of C, and tan of C. So now I'm starting from angle C. Same triangle, different starting point. So sine is, again, opposite over hypotenuse. So from angle C, which side is the opposite side? It's 3, guys. So it should be 3 over hypotenuse is still 5. All right. From C, we now need to know the cosine. So what's adjacent to C? To C, what's adjacent is the 5. I'm sorry, it's the 4. Went right to it, saying 5. For C, what's adjacent is the 4. So it's going to be 4. And then again, the hypotenuse is still 5. So it's going to be 4/5. And then lastly, for tangent, it's opposite over adjacent. So again, that's going to be opposite on top, 3 over 4. All right, so now let's move on to angle B. Sine B, cos B, tan B. All right, so here we are for angle B. Now, from the start, most of you should be confused. Sine is opposite over hypotenuse. So if we go opposite angle B, that is the hypotenuse. So that's the first kind of one where it should be like, wait, what? In addition, if we thought about the cos of B, both of these are adjacent. So we have an issue there as well. Basically, what I'm getting to, guys, it's never, when it comes to these trig ratios, it's never going to be for the right angle. Never the right angle. So it would never be for angle B. It's always going to be for the other two angles. So like A and C, yes, but never for the right angle. One other thing I do want to address is when it comes to these trig ratios, you do just want to make sure you are reducing. Again, it's not much to this section. We're just writing the ratios. But let's say we got an answer that was like, 10 over 15. Again, once we actually start in the next day or so solving these, you won't have to reduce anything, etc. But right now, as long as you're only writing the ratio, if the question is just writing the ratios, they should be reduced. So you shouldn't leave an answer as like 10/15. You should be reducing it. 5 goes into both of these, so it should be like 2/3. So just keep, that in mind, that you want to be looking out for any opportunities to reduce. All right, so we're going to look at a couple of problems from page 1. We'll do number 1 together. Number 1 asks for the tan of x and the tan of y. This is not like the do now number 1, but the number 1 that's like after that guy. All right, and it's the triangle. This is x, z, and y. 9, 40, and 41. Okay, so this is actually for the tan of x and the tan of y. So for the tan of x, tan of y. First of all, again, tan. I like to write my mnemonic, SOHCAHTOA. So we know that tangent is opposite over adjacent. So here we'll start with x, tan of x. What is opposite x? So first of all, this is the hypotenuse. Again, identify that so you don't confuse it. That's h. It's out of the, basically we don't need it right now because it's not the opposite, it's not the adjacent. And we know for this one we're only dealing with opposite and adjacent for tangent. So for tan of x, it's opposite 40 over adjacent 9. For tan of y, we're over here, opposite y is 9 over 40. That's that. For number 5, let's look at that one. For number 5, here's our triangle. 51, 25, and here's angle R. And for this one, we're asked for the sine of R and the cos of R. So the sine of R, here's angle R. Sine is again opposite over hypotenuse. So from R, the opposite side is 24. The hypotenuse is 51. Now I know that 51 probably isn't something you're thinking of as a factor, but again, you want to make sure you're reducing, and this can actually be reduced. They can both be divided by 3 or reduced by 3. It's going to be 8/17. The cos of R is adjacent over hypotenuse. So for the cos of R, this is the adjacent side, 45, and the hypotenuse is 51. Again, they can both be divided by 3. 15, that's 7. Sorry. 15, 7. Oh, okay. It's not going to be circle, but whatever. Do that. There we go. 15, 17. All right. And one last quick thing. Let's look at number 13 on the first page. For that one, I'm pretty sure everyone would know what to do, but I just want to address it just in case. Because there's one or two like this on page 2. For something like number 13, you have 6, you have x, and you have 10. And here's angle B. I just want to be clear that sorry, I should be here. What I don't want to happen here is I do not want you to write the sine of B is opposite adjacent. I'm sorry, opposite over hypotenuse, and then you tell me x over 10. No. What I do want you to do here, and what I do expect you to do, is to find the missing side. So for this one, you would need to find the missing side first, and you could do that with Pythagorean theorem. Equals 10 squared. And once you find the missing side, then you can plug that in, etc. But it should not be like x over 10. All right, guys, that's good. Again, homework is to finish pages 1 and 2. Have a great night. Hope the sound is better on this one. I just totally recorded one and the sound was horrible. Wasted 16 minutes. Anyway, have a good night, guys.